Good morning. I am Dr. Sundara Vadivel. In this lecture, we are going to see the scope of mechanical engineering, which is coming under the subject Basic Civil and Mechanical Engineering of Anna University syllabus. So it shows the overview of mechanical engineering contributions to the welfare of society, specialized subdisciplines in mechanical engineering. Civil and mechanical engineering are the oldest and twin core branches of engineering and technology. Mechanical engineering is a broad based branch with applications in various types of industries world over, including the field of computer applications. What is mechanical engineering? Mechanical engineering is the discipline that applies engineering, physics, and material science principles to design, analyze, manufacture, and maintain mechanical systems. Various disciplines of mechanical engineering are applied mechanics, dynamics, fluid mechanics, thermodynamics, heat transfer, and production technology. Now let us see the contribution of mechanical engineering to the welfare of society. So as the first one is the energy solution. Society badly needs more power. Huge shortage of electricity is there, and fuel pricing also rises up so much. Mechanical engineers should find a green way for this. The transportation solution is the second. Millions of people die every year during traveling. Safety has to be the priority while designing new vehicles. Cost effective products should be produced, and so on. Then he covers the development and implementation of solutions of energy and water needs of the society with minimum environmental impact. Mechanical engineers design, develops materials, manufacture and maintain mechanical devices for broad range of applications in all forms of industry. Mechanical engineering principles are employed in wide range of industries such as power generation, manufacturing, energy, repair, maintenance, automation, and robotics, and so on. The various subdivisions of mechanical engineering are protection engineering, automobile engineering, energy engineering, machine design, thermal engineering, automobile engineering, then CAD, CAM, SIM, and industrial engineering. So basically, production engineering is a combination of manufacturing engineering, industrial engineering, and management principles. What is production engineering? Production engineering accomplish production process in a smoothest and most effective and economic way. Mechanical engineering with the focus on machine tools, material science, tribology, and quality control is known as manufacturing engineer. They are the key personnel in any organization. Production engineering comprises of application of casting and other manufacturing process, machining, joining process, metal cutting, tool design and automation, and etc. What does a production engineer do? Work towards choosing machinery and equipments for the particular manufacturing process. Production engineers will be planning and scheduling the production in any manufacturing industry, example automobile manufacturing, etc. Production engineers will be programming the CNC machines to produce the engineering components such as gears, screw bolts, etc. Responsible for quality control, distribution, and inventory control. These are the basic functions of a production engineer, and still we have some more. The responsibilities of production engineers are plan and coordinate production engineering process on daily basis, develop process improvement to effectively utilize equipment and materials to maximize production, develop operational strategies to achieve production and financial objectives, identify unsafe operations and practices and report the same to the manager immediately, establish safety procedures and environmental regulations for employees, provide engineering support for production and maintenance activities to ensure maximum production, perform engineering analysis to reduce downtime and outages, evaluate current production activities and to make recommendations for improvements, and to implement cost reduction initiatives while maintaining high quality standards, develop operating instructions and equipments and specifications for production activities, provides training and guidance to team members to accomplish protection goals, stay current with product specification, engineering, technology and production process, develop best practices to improve production capacity, quality and reliability, investigate problems, analyze root cause and drive resolutions, aid in budget preparation and monitor expenses and profitability engineering. It is the field of engineering. The production processes can be categorized into metal casting, it is a foundry process, then metal forming, metal joining, and metal cutting. Under metal forming, we have forging, rolling, extrusion, sheet metal forming. Similarly, under metal joining, we have welding, soldering, and brazing. Then, energy engineering. It is the field of engineering dealing with energy efficiency services, facility management, plant engineering, environmental compliance, and alternative energy technology. It combines the knowledge from the field of physics, chemistry, mathematics with economic and environmental engineering practicals. Energy engineers apply their skills to increase efficiency and for the development of renewable source of energy. The main job of the energy engineer is to find the most efficient and sustainable way to operate buildings and manufacturing process. Then energy engineers responsibilities. So they design, develop and build renewable energy technologies. They combine renewable energy pattern with existing power systems. They arrange new supplies with negotiate traffic with fuel provider, carry out site inspection and energy surveys, design and select equipments, use mathematical and computer model to read complete design and specification calculation. And he carry out lab experiments on equipments and adapt them for large scale, prepare a detailed schedule of work, feasibility studies and cost estimates, check site and ground conditions for the installation of renewable technologies such as wind turbines, keep update switch with the legislation and environmental standards, develop technical expertise in all matters. Then applications of energy engineering. So energy engineering is widely applied in modern electric as well as wireless, nuclear technology, then GPS dynamic flight simulations, Tesla coil, then steam engine, rotary engine, heat pump, steam and gas turbines, and aerodynamics. So we can see the wide applications of energy engineering from these figures. So the industrial pollution is very high, it is rising day and day, and so many renewable sources, so many persons are working to get extract more power through renewable sources of energy. So it is called green energy. So the mechanical engineer strives to get more energy through green. That is the main role of energy engineer. Then the next one is automobile engineering. Automobile is a vehicle driven by an internal combustion engine and it is used for transportation of passengers, goods on the ground. Automobile can also be defined as vehicle which can be moved by itself. Examples: car, bus, truck, scooter, etc. Automobile engineering deals with the various types of automobiles and their mechanisms and engines. Basically, the automobile engines works on auto cycle or diesel cycle. Different types of fuel burnt inside the cylinder at higher temperature, and then the chemical energy is converted into mechanical energy, and it is transmitted through transmission lines. Transmission. the classifications of automobiles, it can be broadly classified into basically goods vehicle and passenger vehicle. Similarly, both can be further classified into light vehicles and heavy vehicles. Then light vehicles include scooter, motorcycle, moped, car, three-wheelers. Heavy vehicles are buses, coaches, like that. And for goods vehicle, we have this sort of subdivisions as shown in the figure. And these are the various activities taken place in automobile industry. The automobile engineer should design a car. He should be able to assemble the car, the knowledge about assembly of the car, and then of IC engines. He should have the knowledge of IC engines, transmission systems, then inspection team. All these things are shown in this figure. Roles of an automobile engineer. So, assessing project requirements, agreeing and negotiating project budgets, timescales, and specifications with clients, developing and implementing test procedures, building prototypes of components to carry out tests on, organizing and carrying out tests, interpreting and analyzing results and data, and sourcing vehicle components and selecting best material to use, providing technical advice and answering queries from clients, using specialist computer modeling software to produce designs, making improvements to vehicles in response to customer feedback, investigating and solving problems, example mechanical failures, working closely with suppliers, writing reports and documents, undertaking relevant research, supervising junior staff, and giving presentations. What are the key skills needed for automotive engineers? Effective technical and problem solving skills, commercial awareness skill, good attention to detail and creativity, interpersonal and communicational skills, presentation skills, analytical skills, good organizational skills, ability to work as a part of a team. Who are the typical employers of automotive engineers? Tire manufacturers, specialist vehicle design companies, research or test laboratories, motorsport teams, oil and fuel companies, suppliers, and as usual, self employment. Automobile engineering deals with the various types of automobiles, methods of propulsion, their mechanism of transmission, and their applications. Okay, so now let us see the interdisciplinary concepts in civil and mechanical engineering. Each engineering discipline has its own characteristics that distinguish it from other fields. The first one is dynamics. So it deals with the action of loads on bodies in motion. The fundamentals of dynamics are needed in both mechanical and civil engineering. Applications for mechanical engineering will be focusing on statics part, example machine design, as well as dynamics part, machine tool and automobiles, whereas a civil engineer will be focusing usually on the static part, example constructing bridges, buildings, dams, and dynamic part, example seismic behavior, environmental changes. Similarly, these things will be used for design of machines for mechanical engineering and design of structures for civil engineering. Then mechanical engineers need to know the loads acting on a sliding piston engine on an automobile. Would civil engineers need to calculate hydrostatic force exerted by rising water? Then strength of materials and fluid mechanics are good topics which are most common for both the branches. So it is the base. Strength of materials is the base for machine design, and for civil engineer it is the base for concrete and steel timber design. Similarly, fluid mechanics, both the mechanical and the civil engineers concentrates more on fluids. Mechanical engineer mainly concentrates on water and other all types of fluids including air, whereas civil engineer concentrates mainly on water. So what are the questions we can expect from this topic is shown in this slide. What are the various contributions of a mechanical